Howdy. Maybe you have seen this already several times. Maybe not, but that's the surface conductivity anomaly map I found once. This is the original, and it's a screenshot. And there would have been much more information, but the whole page isn't on the internet anymore. And despite my attempts to ask them stuff about this, they never answered. So, what's left is the screenshot. And I was playing around with this, try to fit it onto Google Earth map as accurately as possible, since it's not possible to make overlays. You know, a screenshot on top of a screenshot on top of a screenshot. And I was drawing lines, circles, lines, circles again. And that's the polar cusp, like, you know, Earth and Earth's magnetic field. And that's the cusp reconnection observations or whatsoever. I don't know exactly what that is, but this is something scientific. And the polar cusp is up here. So it's way out there. But interestingly enough, it has somehow similar features to this surface conductivity anomaly. And I found this whole surface conductivity anomaly because I noticed some repetitive weather pattern. And there has been another repetitive weather pattern I have been following for quite some time, and there has been some maps I found which somehow could explain it in a way. But now I think I found something really interesting also about weather patterns. And that's the reason why I have been searching for this all the time. And today, I think I probably found something. But let's go first to windy. And that's rain and thunder on windy. Rain and thunder. And these are forecasts, so you have to take them with a grain of salt. But let's just play that and let's draw a line somewhere here. It is maybe not at the really exact place, but now let's just watch a little bit, because it is also in this visible to some extent. And we have to remember that these things are fluctuating. So it's not a machine, it's not always exactly like that. So it will fluctuate. Maybe I take the line. You know now where the line is. Like I said, it might be not in the correct place after all. But there is something here which triggers precipitation. Let's say like that. And sometimes it's also with the cold weather. The cold stops. It's coming from the east and it stops somewhere here and it doesn't go any further. Yeah, now it's really easily visible. Now we have a nice line. I didn't watch it that long earlier. I just thought it's somehow visible. You see that there is this kind of thing here. So that's the European plate MOHO depth map. But before we take a look at the map, we want to read quickly this. Introduction: the seismic discontinuity discovered by Andrija Mohorovic in 1859, or he lived from 1859 to 1936, is a primary definition of the boundary between crust and upper mantle given in terms of velocities of seismic waves. Today, the seismologically defined Earth's crust means the outer shell of our planet, in which the velocity of P waves is smaller than about 7.6 kilometers per second, and S wave velocity is smaller than about 4.4 kilometers per second. In general, P wave velocity in the lower crust is about 7 kilometers per second and the uppermost mantle about 8 kilometers per second. So the P wave velocity contrast at the MOHO discontinuity is quite large, being up to 1 to 1.5 kilometers per second. This indicates a significant change in elastic parameters resulting from significant change in the rock types between crust and the uppermost mantle. Secondary definitions of the Earth's crust use other parameters such as densities, type of rock, mineralogical and chemical compositions in the density definition of the crust. The density value corresponding to the MOHO is 3.1 grams per cubic centimeters. The typical density of the lower crust is about 3, and for the uppermost mantle about 3.3. So also in terms of density, the MOHO is a distinct discontinuity. The MOHO. I missed. Let's try again. Yeah, the MOHO. And somehow I didn't really have time yet to dive into that. It's very interesting. It might be, maybe, water. Maybe not in the form we are used to see water, but it might be water. It might be a boundary, some threshold boundary for hydrogen. But anyway, you saw the windy map before, and now let's have a look at this map. That's the whole paper. There are several other pictures, but we just focus on this. And for those, obviously, that's an interesting area. And I think it's really hard somehow to... Yeah, I'm somewhere here. Interesting. Yeah, it's a special place, I know. But anyway, we have... Here is Denmark. I don't really... Do they have borders of countries here, or are these... They have. So, if we watch Next Time Windy, we might have to keep in mind not only this region, but also this region here, and this region here. And I think that is the Kursk magnetic anomaly. It goes until down to the Ukraine and stuff. But here, it seems to be very interesting. It seems to be very deep. And here it seems to be very shallow, close to the surface. Which could also mean that there is much more heat just beneath the surface. And I just wanted to show you that, like, very often you see weather patterns which are, now let's say, use or this boundary, which is 50 kilometers, maybe, or more, 50, 60 kilometers beneath the surface, gets reflected in the sky by weather patterns, rain and stuff. Like I have been saying many times before, if there is bad weather over your head, there is bad weather under your feet too. Of course, the weather underneath your feet is different from the weather above your head, but they're always connected. And maybe there's some kind of formula. Yeah, I probably lean very far out of my window. Let's say this is the surface. And let's say these are some layers underneath the surface. And let's just imagine this would be layers above the surface, atmospheric layers. And is there any formula or whatsoever which could somehow predict or whatsoever, like, I don't know, I have been pondering about this for a while. If we have weather going on in this atmospheric layer, whatever it will be, would it be action beneath the surface? Like, if this would be 4 kilometers, could the action? No, I draw 4 kilometers. Would this be then 40 kilometers? Something like that, you know? Or is it the half of it, or 15 times the amount, or whatsoever? There might be something like that, If you could see the weather like behaving like it does, we have high clouds, low clouds, and all these kind of things. Could there be any conclusions made about what's going on underground just by taking the height of the atmospheric disturbance? Might it be a thunderstorm or whatever? The strength of a high pressure system or a low pressure system? The stronger it is, the deeper it influences the stuff beneath your feet. For example, water. I don't know. But I think that's a very interesting map, which probably should be used more in weather predictions and all these kind of things. And there are like other maps here, the Baltic Shield and all kinds of things. Yeah, but anyway, I think I leave it here. I don't know if you got anything out of that, but sometimes it's a bit hard to explain because, like, it's freestyle, no notes made or whatsoever. And quite often I just find new stuff while doing a video about something and 110,000 other things thinking about. But that's very interesting. I have to really check out where I am on this map. I'm in this really dark area. Interesting. Interesting. Especially with having those plasma rocks and all these kind of things here. Yes. Thanks. Well, let's hope that this stays on the internet, this map. And I will put a link below to this, and you can check it out. If you live in Europe, probably you will find yourself somewhere in an interesting spot. But yeah. Thanks. Bye.